Hello chemistry fans, and welcome back to chemistry problem solving session here at the Academic Success Center on Broward College North Campus. I am your host, Dr. Russell Betts, and I'll be guiding you through this problem today. So now, without any further ado, let's jump right in. Draw the expanded structural formula, the condensed structural formula, and the skeletal formula for pentane, C5H12. Okay? Expanded structural formula. What that essentially means is we're going to draw all the atoms and all the bonds. We're not going to abbreviate anything. We're not going to shorten anything. We're just going to draw everything out, show all the atoms and all the bonds. So it's a pentane, so it's C5. So draw 5 carbons in a row. 1, 2, 3, 4, 5. Now, we also have to draw all the hydrogens in. And we know that every carbon must have 4 bonds, no exceptions. So this carbon right here only has 1. So the rest of the remaining bonds have to be bonds to hydrogen. And I'm drawing the bond out like that. So I show the bond and the atom. Here it's 2 to give a total of 4. 1, 2, 3, 4 bonds around the carbon. Same thing here. 1, 2, 3, 4 bonds around carbon. Carbon always has to have 4 bonds. 1, 2, 3, 4. One, two, three, 4. Okay? Carbon always has 4 bonds. Now, I think, looking at that, you guys are all saying, well, that's kind of a lot. That's like a lot going on right there. It's kind of hard to look at, really. It's kind of hard to decipher what's happening here and there. So there must be an easier, more concise, more condensed way of doing this. And we do have the condensed structural formula. So now, what the condensed structural formula does is it condenses all the carbon-hydrogen bonds down. And instead of drawing C with 3 bonds to hydrogen, we simply draw CH3. This carbon and these 3 hydrogens are now included right here. Line CH2. This CH2 is now right here. Instead of drawing the bonds to hydrogen, we just abbreviate it, CH2. Pretty simple, I think, right? And again, CH2 comes from here. So now the next one is this one. So it's going to be another CH2, right? Right? I hope that you're seeing that pretty clearly. And I'm using different color markers just to emphasize the point. On an exam, you would just use whatever color, pencil, blue, black, red, yellow, whatever. Please don't use yellow. Hard to see. There you go. That's a condensed structural formula. I think you will agree it's much easier on the eye than that one. This one shows all the detail, though. This one eliminates some of the detail, but makes it easier to read. Now, the skeletal formula, I sometimes will refer to them as line drawings in class. It's just kind of a jargon that some organic chemists use. A line drawing or a skeletal formula takes out all the atoms. There are no atoms at all in this drawing. It's let me say it a little differently. There are no carbon and hydrogens drawn in these drawings. Any other atom is shown. So for example, if there was a bromine on the molecule, it would show up. You would have to draw bromine. But if it's carbon or hydrogen, you simply don't draw it. Okay? But how do we tell people what we're dealing with? We simply draw a line. That's what it would look like. This is this. Now you're probably thinking to yourself, how can this be that? Great question. Basically, all you got to do is when a line terminates. So here we have a line ending right here. This is a CH3. Whenever a line terminates, is a CH3. So there's a CH3 there and a CH3 there because the lines abruptly terminate. They stop right there. Wherever 2 or more lines come together, so here our two lines here coming together to a point, that is a carbon. This is a carbon, that's a carbon. So here's a carbon here, carbon here, carbon here, carbon here, and a carbon there. Okay? Now remember, carbon always has to have 4 bonds. So here we have a carbon sitting here. It has to have 3 other bonds because carbon must have 4, right? So there's a CH3 here. There's a carbon sitting where those two lines come together. So this carbon has 2 bonds coming to it. So it must be a CH2 there, okay? Because it already has 2 bonds. All right? So this is a CH3, CH2, 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 CH3. All right? Now the skeletal formula is a little weird. It's a little hard to get at first, but once you get it and master it, it's actually the preferred way of drawing organic molecules because it is so much easier and so much more clear. Once you get the hang of looking at them, you will prefer this way. Everybody does. Okay? Now with that, I hope that you were able to follow along and get something out of this video. If you have any trouble or have any further questions, please don't hesitate to ask one of the tutors here at the Academic Success Center. They are here to help you. Or, if alternatively, come on by my office hours and I will be more than happy to help you out with this problem. All right? Now with that, I wish you good luck and good chemistry.